So it says that there are three spheres in which that you have the same charge q. So all three spheres are conducting spheres, and you know, in a conducting sphere, the charge is being held on its surface. So if it's a positive charge, the charge is being held on its surface like this. So all of these three keep their charges on the surfaces. And the method of finding intensity around a charged object is just to use Gauss theorem, and Gauss theorem is a very simple tool to use. It's a tool actually. You can use the tool to find out what the intensity is. So what would you do is that first you mark the charge distribution, then the flux distribution, then the Gaussian surface, then you apply the equation. So there are 4 steps. First one is to find the charge distribution, which we have done. Second one is to find the flux distribution, which we also know. You can mark the flux going out of all the 3 spheres like this. So all are the same like that. And then our task is to apply the Gaussian surface, introducing the Gaussian surface. So I'm going to introduce the Gaussian surface like this. So you can see this surface is the surface should go through the point at which that we want to find the intensity, as well as the force field lines must be completely perpendicular or partly perpendicular and partly parallel. So here we can find a Gaussian surface which is completely perpendicular to the flux. So then what we are going to do, we are going to apply the equation. There are 2 equations for flux. Gauss said it's q over epsilon, and there was another equation EA. We are going to equate those 2 equations. EA is equal to q over epsilon. You need to know clearly what the meanings of these are, right? So this is the charge inside the Gaussian surface, this is the area perpendicular to the flux, and this is the epsilon value. So when you do this for all of these 3, right? So for EA, what you can write is q over A. A means the area of the sphere, 4 pi r squared epsilon naught. If it's A, it's epsilon naught. For EB, simply again it's q, because the charge inside the Gaussian surface, when you take B, when you take B, you have to consider a sphere like this. When you take C also, you have to consider a sphere like this. So all the spheres here are identical, right? All the spheres have the same radius, so same surface area. So all of the spheres will give us the same value, and EC is also the same, 4 pi r squared epsilon naught. So it's the same, right? So EA is equal to EB is equal to EC. Answer 2.